السلام عليكم مرحبا بكم معنا in another webinar in our series Advanced in Geoscience and Geoenergies. معكم محمد عمروش. I am the project leader, and this month we are very, very pleased and honored to have Dr. Mohammed Zin Abidin Darman with us this month. Assalamu alaikum, doctor. Thank you very much for accepting our invitation.
Never mind, you are welcome. It's a great pleasure to be among you and to present this work. Do this.
Thank you very much. Thank you very much, Doctor. So I just recall the project. This project aims to invite experts in the oil and field and the energy sector in Algeria in order to introduce and share their expertise and share science with us in a public webinar. We also have with us Sarah Killal. Assalamu alaikum, Sarah. Thank you very much for joining with us today. So maybe I will give the mic to Sarah to introduce our speaker today. تفضلي Sarah.
So good morning, good afternoon, and good evening to everyone who's joining in, and welcome to INES monthly webinars. Thank you so much for staying faithful for INES events, and today we have the honor to present to you another webinar under the project of Advances in Geoenergies and Renewables, welcoming another Algerian figure, Mohammed Zin Abidin Darman, who will be presenting projects in petrophysics by combining artificial intelligence in this field. So before we start, I just wanted to take a moment to present our speaker for today's event. So Mohammed Zin Abidin Darman, who was born in Boussaida, Algeria. He holds a PhD degree in electrical engineering from the Faculty of Hydrocarbon and Chemistry, University of Boumardès, Algeria, magister degree in geophysics from EAP, and a magister degree in applied automatics from Department of Automation and Electrification of Industrial Process, Faculty of Hydrocarbons and Chemistry, University of Boumardès. Another engineering degree from the National Institute of Electrical and Electronic Engineering, ENELEC, Boumardès, Algeria. Currently, he's the member in LAA Research Laboratory, University of Boumardès, and his current research interest is reservoir evaluation and optimization of control design for complex systems in petroleum engineering. So with no further ado, let's give a warm welcome to Dr. Mohammed Darman. Thank you so much for accepting our invitation, and the mic is yours.
Thank you so much, Sarah. Thank you so much, Amos. It's a great pleasure for me to be among you. I would like first to thank INES, thanks Sarah and Amos for giving me this opportunity. It's a great pleasure for me, and I will try to give the best for you and for the audience. So I will just start sharing my presentation with you and make sure that you can see it. So I will just share it first. And please let me know if you can see the presentation as soon as we can see it.
Yes, we can see it. Just please close the small window, hide the small window.
Of course.
Yes.
Okay. So the title of this presentation is Application of Artificial Intelligence for Petrophysical Evaluation of Reservoirs in Algeria, Challenges and Limitation. So this presentation is done directly from the Department of Reservoir and Evaluation, Direction of Exploration, Division of Direction of Exploration Operations, Division of Exploration of Sonatak. So the outline of this presentation. So I'll start first by introduction and objectives in order to give the audience the framework of this webinar and why we do it. Then I will just give you a detailed look about the AI trending in academia and industries. Then I will just give case studies, how the AI is changing the oil and gas world industry with examples of ongoing projects all over the world, especially from giants of the petroleum fields. Then what are the prioritized projects, dimensions, strategies, and the relation with its difficulty. Then I will give you some demonstrations how the artificial intelligence is transforming the oil and gas industries, and also the market of oil and gas industry and trends from 2020 to 2025. So then I'll try to answer the main question to give an answer for the question, where can we apply the artificial intelligence for Algerian petroleum industries, and with some examples and case studies from exploration and production activities. At the end of this presentation, I'll try to give some conclusions and recommendations. I will give also some questions. So the artificial intelligence is a discipline, very important discipline that concerns with the process of modeling and that allows the machine to perform tasks related generally to human intelligence. So, for example, learning, dialogues, reasoning, understanding of languages, and everything. So, why we should apply artificial intelligence first? Because it can give us an opportunity to solve problems that have never been solved before. Also, it will help the managers to give speed decision making and increase the efficiency and reducing the cost for exploration and production activities, for example. So we can see that artificial intelligence can be applied anywhere and everywhere in the world. So for example, for health, industry, for energy, for industry 4.0, for productive maintenance, for automotive industries, autonomous vehicles, and everything from smart cities to smart building to smartphones to anything, even for defense and other things like that. So we can see that artificial intelligence can be divided into different topics or subjects, or let's say used for modeling of equations or something like that. For example, automatic natural language processing also is very important discipline, where the translation of languages and the communication between humans will be much easier with such a discipline. For robotics too is widely used. For knowledge representation, how can we represent an information and how can we extract another information from given ones, and automated reasoning. So this is very important ones. Also, it is used for data mining and for deep learning too. Deep learning is let's say it is one of the derivatives analysis. For example, the prediction of oil prices. They use too many algorithms of artificial intelligence in order to predict the oil prices and the markets. Also, artifacts, everything, almost everything in human lives. Just a minute. So, yeah, just a minute. So, there are two types of artificial intelligence based on scientists, which are the connectionist and the symbolist. The connectionist is related to everything related with artificial intelligence, machine learning, deep learning, and it is facing tremendous development in the last few years because it allows the human being to find solutions to a specific problem based on based on detailed information. And there are other types of researchers who see the symbolic kind that concerns the formal reasoning and logics. What is logic, and how can we modelize the reasoning of a human being, and how can we model the creativity of human beings? So they said that, for example, anything that can be demonstrated and broke into different parts or into different information can be modeled by artificial intelligence. So, as an example, for example, Pascal has been developed in 1642 that can only do some operations like addition and subtraction. However, Leibniz tried to, from addition and subtraction, find a way to apply it for division and multiplication for complex tasks too. So when we see the history of artificial intelligence from 1943 till now, we see tremendous development with ups and downs. For example, Macintosh, when he wrote his first paper in 1943, he used artificial intelligence to solve some easy problems like imitation games. Then, with the downs of what the question is in the 1970s, where the question appeared, what can computer do? The human being have faced too many, let's say, drawbacks of artificial intelligence, since there are no computational capacities enough to run such algorithms. After that, with the development of electronics, we have seen, let's say, a big bang of the information from there. Where, for example, in 1997, the machine, let's say, Deep Blue machine, has beaten Kasparov for chess game. And from there, in 2010, we started talking about ethics of artificial intelligence and laws of artificial intelligence. And in 2017, we have seen the first humanoid robot, which is named Sophia, and which can do many tasks. And by the way, she wrote a paper about the domination of artificial intelligence and machine on the human. Also, from economic part, we can see that the artificial intelligence has gained too much trust of the human of the researchers since it developed a big market, which, for example, for static image recognition, for example, it gained $8 billion from 2016 till 2025, which is a prediction, by the way. Also, for petroleum field, for example, you can find the predictive maintenance, which is now can allow to optimize till $4 billion, and also for seismic data and something and big data. So for the application of artificial intelligence in petroleum field, we can see the giant of petroleum and gas, oil and gas industries working on that. For example, Chevron has launched the CISoft, which is Center for Interface of Smart Oil Technologies. They develop a kind of smart field where the production, the prediction of production and optimization of parameters are done in real time and in smart way. Texas and AM, for example, with ExxonMobil and Weatherford, they launched together what we call the Center for Petroleum Asset Risk Management, and they use too many different techniques in order to implement what we call smart oil fields. From another side, another project are for different companies. They launched together what we call the National EOR Center in Norway, which its main objective is to save huge computational costs and capture the most important physics and mechanics affecting production predictions and value of information for EOR. So it means we see that the giants of artificial intelligence are all investing time and money for these technologies and techniques. What is noticed a lot is that artificial intelligence is directly related to the digitalization process. If you don't have data, you cannot use artificial intelligence. So for that reason, digitalization is a very important step. What we have noticed in the last few years that the downstream sector, for example, for the commercialization of the products and the factories are facing too much digitalization than upstream. And this is mainly due to the electronic equipment that have been used there and the sensors. For the midstream is catching up. So it means for transportation, for example, is catching up and trying to use too many different sensors and equipment in order to digitalize the information and try to find many solutions. And for downstream, the artificial intelligence is just a new approach since that too many other process that has not been yet digitalized. So that's why it is very important to use. And based on researchers, we can save from 10 to 20% of the exploration and production activities in the downstream if we arrive to implement such approaches. So if we see this this approach from two different sides, from one side we have to digitalize the information, but at the same time we have to make sure that we have a good cybersecurity. So it means the investment in digitalization should be go together with the cybersecurity investment. For the subsea, if you want to invest in subseas, you have to invest in pipelines and avoid problems of collisions. And so on. For example, for enhanced recovery, advanced materials, and smart oil fields, and so on. So these two aspects should go together: digitalization, security, the information, and the protection of the information itself. So if we say the era of time from 1998 till 2022, we see that we have tremendous development from these years. However, there are too many remarkable, let's say, events, for example, for China, Europe, United States, and the other countries all over the world. So from the first robot that had been developed in Japan for cleaning, till Duplex, Google Duplex, and Google DeepMind in 2018. So we have too many steps. For example, China have launched its national medium-long program for the development of science and technologies in 2004, and they have invested a lot in artificial intelligence. Then, a couple of just 1 year after, Princeton University have launched the first driving car in 2005, and in 2006, Europe has launched FP7 funding program, which is dedicated to research and development in artificial intelligence. And then in 2008, with the financial crisis, we have seen also the appearance of speech recognition on smartphones and something like that. Also, just 5 years after the Princeton University, Google autonomous car has been launched in 2009, and so on. So we see that the main countries of the world, or let's say giant countries of the world, are trying to develop new strategies and techniques. However, it should be mentioned also that in 2015, a letter against autonomous weapon has been sent to the United Nations, since there's a moral problem here. How can a machine decide who lives or dies? So this is a big problem, and this is a big problematic that can be discussed a lot. But in 2015, we have a letter against these weapons, and should be considered. And in 2020, Algeria also has launched its own program of artificial intelligence, which is 2020-2030. And most of you know that the School of Artificial Intelligence that has been launched in 2021 is just a result of this strategy. The three barriers to industry growth are the following. So the first one is, let's say, for the last 4 years, is the low prices. So the low oil prices has direct effects on the investment on artificial intelligence, and also weak global economy and economic gas oil prices. And this is the main problem that's repeated for all years, except for the year 2017, where we have seen that oversupply of oil and gas can also be a problem in the investment generally for a company, and also especially for artificial intelligence. So now, since the oil and gas are just increasing up, so I think it's a good moment to invest in artificial intelligence and developing new techniques and approaches. So the AI trending and digital AI is seeing tremendous development in the world. So for the market of digitalization is the energy sector, including things like sensor data collection and analytics. It is expected to grow to $64 billion by 2025. So the application of artificial intelligence now, it's not let's say an optional, but it is a must, because it will optimize too many things. And today, increased focus on digitalization is linked to the industry drive toward the greater cost efficiency. So AI is helping the oil and gas industry chart its future courses. So I will just give some examples from different countries around the world. I'll start with ExxonMobil, who launched a collaboration with 80 universities in the US and abroad the world to develop robots for ocean exploration. Well, ExxonMobil has just committed to reported that it will invest 25 billion over 5 years to support energy research on MIT. MIT is one of the best schools in the world, and the company has reported to invest 7 billion since 2000 for research and development for the objective of deploying emissions and reducing technologies. Let's say Hans Thoman, I'm quoting from Hans Thoman, who is senior scientist advisor at ExxonMobil and visiting scholar at MIT too. He said that we work with MIT on spectrum of programs, intentionally opening the aperture of our lens to look at things we normally wouldn't look at, and we focus on the fundamental science, working with experts across diverse fields at the university to gain deep knowledge and advance those fields. Another example is from the Royal Dutch Shell, which is the first company in the world of so it means a company that works in lubricant sector to launch AI assistant for customers. AI virtual assistant is named Emma. I don't know why it is Emma, but it's named Emma, and it can do many tasks at the same time. For example, it can handle over 100,000 data sheets for 3,000 products, provide information on 18,000 different pack sizes, and understand 16,500 physical characteristics of lubricants, and also at the same time matches share product to 10,000 competitive products. So it is a huge task that can be only done by an assistant, a virtual assistant. And unfortunately, this assistant is available only in the US and UK, but they are working in another assistant named Match, which reportedly provides over 2 million products recommendation to share customers and annually accessible across 138 countries in 21 languages. So the main objective of this assistant is to help the customers choose the best product of shells. So they improve their efficiency of this assistance, improve the efficiency of the product and process operations. And in the future, Shell is willing to invest more in AI industry, not just for chatbots, but also for the process, their main processes. A third example is from Total. Total has launched in a couple of years a competition, international competition named Argos. Argos is a competition of developing what we call automated robot for gas and oil services. And the condition for this competition is that the robot should be able to carry out inspections and able to detect abnormal equipment activities and intervene in emergencies. So it is interactive robots. And Argonauts is a robot designed by a team from Austria and Germany, and most of them are students who won this competition with the Argonaut robot. And they invest a lot total in these winners in order to make this robot work in operational mode. Also, Total has worked in collaboration with Google Cloud in order to develop a system that analyzes the subsurface data, aiming to improving the exploration and production processes, from analyzing seismic activity in a potential field. The software that could not just analyze the image files, but correlate them with the finding information extracted from technical document and summarize this information into queryable AI assistant that can answer questions on subsurface data in natural language. So it means it will just gather information as a bit that will try to answer questions to the users in natural language. And this is a huge task. Another example is from Gazprom, who has invested with the Yandex Data Factory. It is a small company in different tasks. For example, for drilling and well completion, they want to drill to develop smart drilling and well completion equipment, modeling oil refining strategies, and optimize other technological processes. So the main objective of AI for Gazprom is for optimization purposes. And as said, Alexander Khaitin, who is CEO of Yandex Data Factory, said, I'm quoting here, oil and gas is one of the most exciting industries currently since it involves massive volume of data, and any easy solution for optimizing production and businesses processes have long since been implemented. So it means the vision is that to use AI in order to find easy solutions to complex problems. So also it should be noted that Gazprom is working all the time as collaboration with others. So they don't develop their own softwares, but they collaborate with others in order to find a solution for their problems. Another example is from Baker Hughes and NVIDIA. NVIDIA is known as one of the biggest leaders of artificial intelligence. So Baker has also has collaborated with NVIDIA to develop analytical AI-based analytics to help oil and gas companies gain insight from data. It means after gathering the data, what can we learn from these ones? Not just for interpretation of seismic inversion or something like that, but also what can we gain for the next step of the evolution of artificial intelligence. Also, they use deep learning based on analytical software that help employees in oil and gas fields make better business decisions based on data they are collecting. Also, oil and gas firms optimize their operation for different environmental conditions. So NVIDIA has too many projects, and you can see here for the chart from 2013, 2014, and 15 that they work a lot with the higher education and research purposes. And we have, as you compare, for example, 2014 and 15, we can see that the oil and gas companies, giant ones, they're investing more in artificial intelligence by collaborating with NVIDIA, as an example. Another example is from British Petroleum, which aiming to exploiting the impact of artificial intelligence on offshore oil and gas. So then they have developed a software-based solution for the, let's say it is a geoscience platform named Sandy. So the Sandy allows British Petroleum to interpret geology, geophysics, historical and reservoir project information by creating what we call knowledge-based graph. So this is a graph that can summarize the process not just from geology to reservoir engineering. And this will help the British Petroleum in order to not just to optimize the process, but also to define workflows for each reservoir or each geological system by itself. In general, we can say that the project that we have seen in all over the world can be prioritized by dimension, strategy matching, and difficulties. So how can it is very questionable. Someone said, for example, how can we, let's say, judge that this problem is difficult or not? There are too many criteria, computational criteria that can be used, and also strategy matching. So, for example, exploration and production data management system, which is a very interesting project, has low difficulty. It's not so difficult to implement it technically, and it has a high strategy matching, so it should be prioritized. For example, D1, let's see what is D1 here. D1 Enterprise Information Portal Mobile. So it is a little bit difficult because there are some processes that cannot be modeled now, since they depend on the intentions of the user itself. And also, it's not highly matching with the strategy of the different companies. So we can see that we can just select this project that are related to they have low or at least average difficulties, and they have a much higher strategy matching. We can summarize that we can say that artificial intelligence is transforming the oil and gas industry, and here is how. So first, the drilling precision. The AI artificial can be designed in order to gain or to model the rate of penetration based on the historical data in order to predict the performance of water drilling system, and not just to predict them, but also to improve them based on the historical data. The production optimization also can be estimated. Can we estimate the production and estimate its parameters like gas lift rate, choke position, net routine of the wells, and artificial lift equipment? These approaches will help the business owners to identify areas of efficiency and develop strategies to maximize productions. Also, for reservoir management, the reservoir can be built and corrected based on training data from wells and seismic. This can be built with a smart field and lead to real reservoir management. So it means the history matching will have a model that converges to the physical model that we have in reservoir, and therefore we can control it on real time. Also, artificial intelligence can transform the upstream sector by inspections. Inspections mean to factories and implement oil and gas procedures that can help inspection of corrosion and let's say different types of errors that happens in the equipment. How can we avoid them? Also, chatbots, which is maybe it's not very important in Algeria, but I think it can be useful too for chatbots. It's let's say a software solution for which we can communicate with the machine and try to improve the performance of the employees based on the chatbots. So this is very interesting and very important part too. And also gas station monitoring and the use of the automatic use of gas stations without need of human being interventions. Also, parameters involved in cutting and transport process can be modelized, and this is not just science fiction or something. It is a real project that has been implemented and being implemented all over the world, not just to model the cuttings and the process of drilling, but also to model other parameters like porosity, permeability, and water saturation and gas saturation, and also improve the control of drilling systems by and we see by minimizing the influence of the borehole cleaning on the logging and drilling. And we will see some examples, real examples about this aspect. Also, another aspect is to use artificial intelligence for smart drilling fluid. And this is a project that has been implemented in the last few years, for which we have drilling fluid that change its parameters, rheology, based on the magnetic field that can be emitted through tools during drillings. So this is very important and can be very helpful, especially for EOR. Also, another aspect is for oil corrosion and risk analysis. So properties of the crude oil of the storage area can be investigated. With digitalizing the knowledge of and delivering maintenance inside, the new engineering might now possible with AI. For example, in California, we have a company named Palo Alto, which has a platform that use data from maintenance in refinery in order to report incidents and also to investigate the problems of these incidents, how to avoid them next. And also they use the data in order to investigate the cause of corrosion and how can we minimize them in the previous stages. Let's go back now to Algeria. In Algeria, I'll just get started by statistics of artificial intelligence in Algeria, and then how can we use it. So Algeria is ranked fourth in terms of scientific production in artificial intelligence. In 2000, this ranking is for 2018, and probably it will be the same. It is remarkable, for example, that Tunisia has less researchers but has much more products. So it means the efficiency of the researchers should be questioned here. Also, in terms of evolution of production of artificial intelligence from 1992 to 2018, we see that there are 137 scientific product that is related directly to artificial intelligence. I don't mean here what we use as artificial intelligence. I mean here what we develop in this in artificial intelligence. So we can see that Algeria is not well ranked, but it is doing too much efforts, especially for 2020, in order to catch up. Also, this is statistics from Google Trending about the looking or searching for the word artificial intelligence from different wilayas in Algeria. Just here I would like to be sorry because this statistics is done on the division of the old division where Algeria is composed of 48 wilayas. Now it is 58, but I think it will not be too much different. We can see that Jaya is the first in 2018, followed by Tlemcen, Boumerdès, Alger, and Annaba. What is noticed here that the wilaya is generally depends on the research centers and the universities. Jaya has a good university, that's why we have too many people who are looking for artificial intelligence. Also Tlemcen, Boumerdès, and Algeria. And for sure the other wilayas too have good universities too. Also, we can see here the statistics of artificial intelligence in terms of students and master thesis and licenses. You can see, for example, from 2016, 2018, and 2017, 2018, you can see that we have a huge increase of interest in terms of forming the student for artificial intelligence, and importantly, only for informatics or computer science, electronics, and automatics. Other disciplines also have artificial intelligence, but it's not well developed. So we hope that in petroleum field, specialty or options, in the next few years, we'll see specialists of artificial intelligence in our petroleum industries. Also, in terms of the PhD thesis, we can see that 2014-18 we have 44 theses who has been defended in artificial intelligence, which has a contribution related directly to the artificial intelligence. In terms of wilaya, we have, for example, 6 in University of Annaba, Oran, and Biskra, for example, and Steve. But these statistics are always relative, so we have to take too many ranges in order to see what are the trends. But I think trends now in 2022 are better than this year. In terms of research centers, we have 158 projects related to artificial intelligence, where 65 of them, for example, in university in research centers related to the government. Okay. However, for research centers out of the government, we have 41 projects. None of them is developing AI techniques for the industry. So this is a big problem. Also, in terms of patterns, we have few patterns in artificial intelligence, 2, 1, 1, so it's too few. And in terms of startup, and we have politics of our country, which encouraging startups. We have seen that in 2018, we have few startups that are developing something related to based on artificial intelligence. However, I think in the next few years, we'll see a tremendous development in this field since it has proved its efficiency. So I will now try to answer the question: where can we apply artificial intelligence for petroleum industry in Algeria? So I think, based on personal experience, first one is exploration uncertainties minimization, minimize uncertainties in exploration, reevaluation of ancient hydrocarbon reserves by AI data-driven models, and control robustness improvement of hydrocarbons and injection by using AI approach. So I think these 3 main tasks that can be done through artificial intelligence in Algeria. Also, in order to do that, we have first to create and validate prioritized projects that summarize the current various Sonatak activities as well as economic benefits. So not just we use artificial intelligence because it is good or it is trending, but we apply it because it gives us economic benefits. And we have to work in collaboration between industry and the university. This is very important. And databases for learning of artificial intelligence, since that data-driven model is very important. Another issue is that we have to have a strategy about developing through open source softwares, Python and C++. I recommend those two programming languages because to allow you develop too many projects on too many artificial intelligence algorithms for the specific problematic. Let's summarize the exploration and production activities. So, for example, for uncertainty analysis of exploration, as you can see, the exploration process starts from geological model till reservoir model, and each time we have some uncertainties due to simplification conditions. If for example, just follow the structure reservoirs, structures. So structures, we have analysis or analyze sensitivity analysis. We have threshold. Also, we build 3D seismic model, 3D seismic model in order to correct the geological model and so on, in order to minimize the uncertainties. After that, from this 3D seismic model, we'll have also uncertainties because we are working on either structural or stratigraphic, but we have to prove the obtained results through drilling wells, and for which we have some uncertainties that can be increased, and that you have to have a zinner, or let's say threshold, for which we cannot accept the obtained results. Unfortunately, we don't have this due to many considerations, and the process of correcting the models is not done all the time, or at least is not done well all the time. That's why we have too many uncertainties. What I've seen through research projects is papers, is that we can let's say decrease the uncertainties through patent theses and papers that have been developed in artificial intelligence. We project them in petroleum industry in order to decrease the uncertainties from the geological model to the geophysical model and the vertical resolution of seismic data to the drilling process and the ops to the petrophysical model, which has too many uncertainties, to the reservoir model and the history matching. So it is all can be minimized. The uncertainties of all this process can be minimized one by one or together through a complete process and using artificial intelligence. So artificial intelligence can be very helpful for this. This is frozen. Okay. Now I will just try to answer these questions. How can we innovate and what are the tools? It's a very important question. The second question is who owns software purchased within a company? So based on my experience, I see that in petroleum industry, we have too many softwares, what we call end user softwares that are first black box and very expensive. Yeah, they should be expensive because they have too much development inside. But the question is, how can I use end user software in order to develop an added value to a company? So it is a big question. And for me, I think we have to go to the research and development in order to develop new approaches that does not exist in the end user softwares in order to implement them for local problem. So for startup, a software startup, and we have to do efforts in open source like Python or C++ in order to develop approaches that does not exist and implement them, test them, and improve them in local. Now I'll just try to give some examples of application of artificial intelligence. One is low resistive reservoirs evaluation. So the objective is first to design a model that allow us to predict the water saturation in a reservoir based on artificial intelligence. Why we should predict this and why the conventional method did not work? Because simply we have low resistive phenomenon. Low resistive phenomenon has appeared in Algeria in let's say a couple of years ago, for which we cannot evaluate the reservoir with certainty with the use of resistivity log. It has been said that it is due to the heavy minerals. Yes, it is the major cause is the underestimation of oil saturation, let's say, or overestimation of water saturation is based on heavy minerals. Yes, but theoretically it is possible to evaluate a reservoir based on resistivity logs with other logs too, since the resistivity indicates the quantity of oil exiting the reservoir. However, due to some cases, we can produce with the reservoir that have 1 ohm meter of resistivity. This is due mainly to the factor related to the environment. One of them is the heavy minerals, and geological factor affecting resistivity measurements too. The solution that has been done in the last few years is that you use different types of logging tools in order to affirm or to confirm the presence of hydrocarbons. Since the resistivity log is not reliable, therefore the SW is overestimated. So we have to use different tools in order to estimate them, like say AMR or MDT or TDT or EPT. So, but the question is, this solution can increase the cost of the operations, the job operations, and this is not cannot be acceptable for in terms of economy. So for that reason, we try to use artificial intelligence as a solution for this. So in consumer logging methods, an increase in conductivity or decrease in resistivity is explained by the existence of reducible water, which is not always correct in some cases. So not only the reducible water is the cause of increase or decrease in conductivities. Also, we used, for example, Archie equation or Simondo equation, which is cannot be reliable for heterogeneous reservoirs. So therefore, we have to do much more efforts in order to evaluate the reservoir. In normal, or let's say in conventional logging interpretation, we to start by QC of the logging data, then we zonations and calculating the volume of the clay from different logs, from porosity and from water station, and which is actually done very well by our colleagues in Department of Reservoir Evaluation. So they're doing great jobs. However, most of these solutions are based on, let's say, suppositions that water formation is the only conductor in the rocks. And when we calculate the resistivity, we can calculate the SW, which is not correct in this case, because the resistivity measured do not represent the formation of water too only, but also other conductive minerals and reducible water too. So therefore, we cannot take complete trust on the obtained results from this equation, either like RC equation or Indonesian equation or Waxman and Smith. So why it is important to have reliable SW? Because simply it will affect directly not only the petrophysical evaluation, but also the estimation of hydrocarbons. So if wrong estimation of SW will directly influence the estimation of SW. So therefore, it is necessary to find another solution, or let's say complete solution for this one. Let's say we have a cube of water here. If we measure the current here, we can directly we suppose that the current can pass through here because it passes only through water. So therefore, from the value of the current we can estimate the value of the volume of the water and its type and the pore pressure too. And here we suppose that the current can pass only through the water of the formation. But if you have conductive minerals, we'll have too many paths over here, and this will not help us calculate the SW correctly, and therefore will not estimate the oil saturation correctly too. So what we have done is just first to analyze the different research works that have been done in this field about resistivity from, let's say, from 1950s to 2017. And we have found too many solutions. So we have tried to adapt our solution for this problem based on the obtained data. Also, we tried to take a look at, let's say, analyze the different tools that have been used for, let's say, for calculation of SW directly without recurse to the resistivity log. There are some people talking about the permittivity, but I'm not sure about what is the difference between permittivity and electrical conductivity. I'm not seeing too much difference in this side. So for conventional reservoir, if we find for conventional reservoirs, the phenomenon of low resistivity has a huge influence on that patient when using the classical model. So in customary log, an increase in conductivity or decrease in resistivity, as explained before, has the direct influence on as is influenced by irreducible water. And also the use of RC equation is not reliable. So therefore, the simplest evaluation technique consists of recognizing hydrocarbon zones using porosity and resistivity logs. If resistivity log is not reliable in this case, we cannot trust that we say that we have a water over here. So we have to look at another methods. The main causes of low resistivity phenomenon in Algeria, I guess, is the thin bed, which is we have thin beds and high speed of the logging. We may have not enough time to measure the current that come back from the emitted tool, and also the supersaline water has a big influence on the resistivity log, and the high irreducible water also, if it exists, it may affect directly the resistivity log and the conductive minerals, let's say chloride, moronite. But in general, we can say we have heterogeneous minerals that influence directly the current. So the conductive minerals, the saturation equation assumes the only conductors in the formation are the formation of water and clay minerals. Modified RC equation count for both. So yeah, modified RC equation can count for the clay minerals, but how about the heterogeneous ones? So a number of conductive minerals can also exist, and they are not corrected. Even if we can correct the clay minerals, it's not sure that we have corrected the conductive minerals too. So what is the solution? Solution in geochemistry. So we have to use some geochemistry in order to see what is the cause, the principal cause. And it has been proved that the chloride in some wells, the chloride is the main conductive mineral that exists in the well. An equation has been also, let's say, proposed with some collection of these conductive minerals, the chloride exactly. But the question is, how can we measure the volume and the resistivity of the chloride for all wells? So we have to use other tools. This is economically unacceptable since we cannot use the mineralogy tool for all wells. It is too expensive and may have no benefits after. So for that reason, what we have done is just to estimate based on the measured volume of the chloride to estimate the quantity of chloride of the near wells. So we have done some wells from which we have the low resistivity phenomenon, and we have trained the algorithm based on these values in order to find the regional value of the chloride and its resistivity in order to apply this equation. The correlation were good, so we have found some good correlations for training and validation. But for the testing, it was not exactly the same, especially when we have too many variation of geological facies in the region. So the obtained results based on this solution is still discussable. But if we have enough data, we can improve the obtained results and maybe to give us new better results. What we have done next is not just to try to compensate the chloride volume and the effect, but also to try to train the algorithm itself based on the saturation calculated from cores in order to replace the equation of Indonesian equation and Waxman-Smith equations or dual water. So we have tried to find a model that replaces these equations. So what we have done is we have just take a couple of wells in Algeria, and from a given well, we have login data, coring, and the saturation, either calculated or measured directly from the cores or calculated from quantity-on. And then we move to another well where we have login data, coring, but we don't have the saturation, or at least we don't have reliable values of saturation. What we have done is use the first one for learning and the second one for prediction. So what we have done also here is that the classical analytical models have been used, used resistive models, and sometimes it's not be applied for other wells or fields for the reason that Omega constant, because it do not need strong correlation between separation models. What I mean here is that we cannot use the same parameters for different wells that they do not depend on the same geological settings. So what we have done is just to combine the ANN with SVM. So SVM is support vector machine. ANN is artificial network, exactly MLP. We have used simple one. We have combined them because we have seen that for artificial intelligence, give the same importance to the input data. And this is one of the drawbacks of artificial intelligence. That's why we have SVM to give a coefficient for each one. So for example, gamma A is not like a porosity curve, and porosity curve is not like pure factors. Each one has its own impact on the SWV. So for that reason, we have given each one its weight, or let's say coefficient. So the first step for the algorithm is to input selection. So we have used the sonic neutron density. Of course, we didn't use resistivity over here, so it's a mistake. So it's photoelectric factor for detection targets, water saturation, which is water saturation here. Also, we have done the step of normalization, data normalization, and it should be noticed also that we have normalized not only the parameters from 0 to 1 or -1 to 1, but also the porosity. Some regions we cannot find porosity higher than 36%. So that's why we have to normalize them between 0 to 36%. The algorithm is described over here. We start by logging data, normalization, classification of input using SVM, and training the algorithm based on water reliable saturation measurements. And after the training, we have the validation based on regional wells than for generalization in the other wells near in the same region. One minute, computer is frozen again. But in the next step, in the next slide, in this slide, you can see the algorithm of details of the algorithm that we have used, where the probabilistic model is designed, and based on the lithology. Not in this case, we didn't use the lithology, but water saturation. Later on, I will talk about the lithology, and we have the calculation of the saturation minus the calculated saturation, and come back to the iteration 2, 3, 4, 5, 6, and so on until convergence to, let's say, a solution or acceptable solution. In this case, we have used 10 to the power minus 6, which is the LMS value of the obtained log minus the reference log. After that, when we find the model, which is not guaranteed, because there's no guarantee of convergence of artificial have to use twice and something like that. And then we keep the same model, calculate the saturation, and validate the results. So this step is for test and results of the algorithms. So one of the most important steps is the function, the function that we can use for activation. We have tried too many functions like polynomial, radial, and sigmoid. We found that the RBF, which is a radial basic function, is the most performant one in this case. So it's not general fact, but in this case, it gives you the best results. Yeah. So in this case, after that, we have just correlated the obtained results from water saturation with the results obtained from the core data. So we have seen that there's a good correlation, but just for some wells. Other wells have no good correlation. So in order to improve this result, or to improve the radius of validation of the algorithm, we have just used too many input data in order to make sure that the obtained results will be sufficient enough. Another example that we are going to discuss now, it is automatic lithophasial circulation using artificial intelligence. So lithophasial classification for the logs is a complex and non-geophysical problem. So it is based on cross-plots and the experience of geologists. So it may depend on the experience of geology itself. Sometimes we have some different opinions about the fascies. So in addition to that, it is so semi-automated, instead a huge amount of data and tedious and time-consuming. So for that reason, we wanted to design an artificial intelligence algorithm that can allow us to predict the lithophasias based on data. So we have taken a couple of wells from a given region. Then we search for the data that exists over there. So for example, the login data, the quarrying, so it means lithophasias and lithology. After that, we'll move to another well from which we have the login data, but we don't have the quarrying. We don't have the lithology. So what we do is design an algorithm that can predict based on the obtained the first well to predict the fascies in the second one. But we have also faced another problem, is that sometimes we cannot find enough data for the logging. So for example, we have gamma ray caliper, resistivity, and neutron density and PF factors for a well, for given well. But we move to another well, not too far from the first one. We have some logging data, but we don't have PF and sonic data logging. So what we have done also here is just to learn the algorithm to predict, but not polarize or interpolate. It's not interpolation. It is a more complex solution based on data. So the obtained result, sorry. So the obtained result over here so the obtained result over here is saying for the well number 1, for which you have the C in the left, the lithology obtained from artificial intelligence, and from the right from geological interpretation. So you can see you have more precision for lithofacies, and also can give good results if enough data is injected to the process, to the learning process. Here another example, another well. You can see here also that artificial sometimes give us new facies that we cannot see through geology equipment, and this can be checked directly through laboratory measurements. Here another example. And here another example. These are some examples of the results that we have obtained. But it should be noticed that artificial intelligence, or this algorithm that we have developed in this case, may not give good results if the data itself is not reliable. So it means that we have good data that are not that are influenced by erroneous values, which will directly influence on the performance of artificial intelligence. However, in general cases, it can give better results in terms of prediction and interpretation of lithofacies for general interpretation or for specific purposes. So what is recommended for this option is to increase the number of wells and use more carrots data for learning. So this the main utility of such approach is that it can be used to minimize the number of carrots and current data that we do for each laboratory. So if we use data enough. Another example I'm seeing here is low resistive, low contrast reservoirs. As I have described before, the low resistive phenomenon now is not just a phenomenon, but it is a type of reservoir. A low contrast, it means there's no contrast between the resistivity, deep and shallow resistivities. Therefore, we cannot see the hydrocarbons over there. So it is in conventional reservoirs, resistivity logs are one of the main records allowing differentiation between the hydrocarbon zones and the water zones due to the large contrast in resistivity that exists. If, however, the reservoir has area of low resistivity with low contrast, these logs became unable to identify these areas and indicate the mobility of the water in place. In the past, there were no enough technologies in order to, because the low resistivity phenomenon is mainly due to the geology. Geology existed for hundreds of millions of years. It's not for today. So this phenomenon exists for forever. So, but we have discovered in the last few years. So before, we may have just omitted or neglected some wells where we can find an interest, petroleum interest. Therefore, I think, and due to the lack of technology in the 1970s, 80s till 90s, so it is good idea to look back at this data again and interpret them using new approaches and new technologies. Even the low resistive low contrast reservoirs has been recently discovered, but its basic resistivity has always existed in Algeria. Thus, in order to correct the underestimation of the volume, because many studies has been carried out, unfortunately, based on conventional empirical methods without any mathematical basis, and therefore difficult to be generalized. So our vision is based on finding another way, another method in order to interpret the reservoir or calculating the SW without passing through the resistivity log. And when you have C and discuss, we find that the sonic log might be the solution. So through sonic log, VP and VS, we can develop an equation. We have already developed an equation that can allow us to calculate the tortuosity. Let's say tortuosity is an indicator of the pore geometry, and therefore the geometry can give us the results of the porosity and based on the different compressibility between the water and the gas, we can separate them for easy. So for oil and gas, oil and water, we can separate them without any problem. For oil and water, due to the near compressibility, it's too difficult, but we can use it as a step for reservoir evaluation. Another aspect we are working on is the smart trading system, or what you call the robotics. So, as you know, in rotating systems, one of the main issues is the stick phenomenon, the violation stick phenomenon, which is the stick of the tool for a couple of seconds due to the rock, the hardness of the rock, and then it will be free and dissipate energies, and these energies may influence or damage the borehole geometry. And this approach, let's say this phenomenon is caused by due to the interaction between the rock and the pit, as you can see in the video over here. So the rock pit interaction will influence directly this phenomenon. And in order, the main equation has been developed in the last few years, like the equation of MOV and different equations from researchers. However, this equation is still suffering from reliability due to the different regions, due to different geologies. So for that reason, what are we going to do is to develop a model, a model based on artificial intelligence in order to arrive to modelize or to model this phenomenon for specific geology, for specific reservoir, and therefore each reservoir can be used. But this solution depends on data and availability of data. So we are working on it. So with the data from black box, tool black box, and robotics, which is technologies of the PC is frozen again, but I will try to, yeah. In this part, we have what we have developed. We have a software solution with the prototype, and this solution can consider the dynamic of rotating system, as you can see here, with a prototype in order to validate experimentally before going to the implementation in rotating systems. And this solution not just consider the dynamic of the two system, but also we have designed different controllers that can allow us not just to minimize the stick slip vibrations, but omit them in real time in 5 seconds. We have arrived to 5-second elimination of stick slip vibrations based on simulation and experimental validation in prototype. We are developing another prototype which is more adequate than this one. But we are developing another better one. Well, the PC is frozen again, but I'll wait for it. Yeah, another project or another example we can see here is positive model construction based on MLFM and seismic inversion. You can, as you know, the seismic inversion is one of the good solutions for reservoir characterization if it is well done. It is based on good correlation with data. What we have done in this part is that we have used supervised learning method to construct a model between the impedance, acoustic impedance, and the porosity. Let's say acoustic impedance VP over VS and ZP over ZS and the density. All these inputs with output is the porosity, and we constructed a model based on data from wells. Then we try to apply the updated model into seismic volume in order to generate a volume of porosity, regional porosity. This approach will allow us to calculate the porosity volume using multi-layer perceptron artificial networks. Applying to an Algerian South hydrocarbons field clearly demonstrate the power of post-processing techniques to predict the porosity. The obtained results can be used for reserve estimation, permeability detection, recovery factor, and reservoir monitoring. we have used, as we said before, MLFN, but it is, since we have used the data, seismic data, it is necessary to, let's say, optimize the parameters of the architecture of artificial intelligence, because for the upscaling process, it will take too much time and computational effort. We have used simple laptop ESETs with 4 cores, and so therefore we needed to optimize the algorithm itself in order to run the process in acceptable time. So we have gone from seismic volume to impedance volume, and we have correlated the acoustic impedance, the impedances from the wells with the impedance obtained from the volume. And then we move to architecture optimization for the number of input layers, number of hidden layers, and number of output layers. So what we have done is that we have used 2 wells used for network learning with the following logs: TTS, gamma ray, caliper, sonic, ruby, and V, and third well for validation. So the first step, we have optimized the hidden layers known as numbers. So it means we have fixed the total iteration number and gradient conjugate iteration numbers. Then we override hidden layers numbers in order to see what is the best correlation values for learning and for correlation and learning. And we find that is 1994. Then we have used fixed the value that you have obtained, which is 94. Then vary the gradient conjugate in iteration numbers in order to find the optimal solution to, as you can see here. And therefore, in the second step, we have also fixed total numbers of iterations and find the optimal solution, as you can see here. So at the end, when we find the optimal solutions, we have optimized the architecture of our algorithm. Then we have applied for the whole seismic volume in order to invert or colorly invert the seismic cube in a reasonable time and computational capacity. Here it is an example of the optical result positive map that we have obtained, and we can see that we have found some very interesting areas for porosity where can be obtained. Yes, it's not enough to obtain porosity. We have to check also for the permeability, but it can be used as a guide for explorers in order to maybe to focus on more regions than the others. So we can conclude for this part that the use of potassium affection in optimizing the real output using the network load has to be for the volume. The inversion of the real seismic data by artificial network give an average result because of the insufficient number of wells. So for sure, the use of 2 wells for correlation might not be enough, for sure. But if we increase the number of wells, we have, for sure, will obtain better results. Another example we can see here is the estimation of logging using artificial networks. So the problematic here is that we have some logs, old logs, where we cannot see anything over here. And in order to digitalize it, just to put correlation and do the curve, it's not practically good. Yeah, it's good for as a solution to use the log as the last file, but it's not good because you have just omitted data. Not omitted, but you have just put the wrong data. So what we have done is we have used artificial intelligence in order to predict what is the missing part here based on the near wells. So what we have done here in this part, we have used different algorithm, which is based on gradient algorithm and Newton ones. We have combined them in the so-called Markov-Levenberg market algorithm, which is based on different way of calculating the synaptic weights based on the synaptic weights of the previous iteration. So this is the main advantage of this one. The learning rules are somehow different than the previous ones, but it has better convergence conditions. So, and also we can also, let's say, manipulate the rate of learning and the neighborhood function. We can summarize this algorithm is that we want to find the relationship between the density and the different logs, pure factor and different logs, sonic factor and different logs, with the condition to minimize the mean square error of the estimated log in comparison to the log of the networks, right? So this is the main summary of the approach. The obtained result for density log is seen here. We can see that for 22 epochs, it gives the best results for density logs. For pure factor, we can find at 48 epochs. Epochs is the number of iterations, so it means if you have a high number of iterations, means we need more capacitive calculations. And for the sonic log, we can find the 21 epochs, but the error, as you can see, between the green and the red one is still considerable. Contrary to the density and PF logs, the sonic estimated log was poor. Yes, for sure. How much it's sure depends. If it's better than correlation or interpolation, anyway. So we have seen that this approach can give good results if enough data has been used. But the main reason why the sonic log was not well estimated is that when we can see that each log has a weight of dependency with other logs. So the pure factor has good weight of dependency with depend strongly to other logs and the density log. However, sonic factor it might be a different weight because it is based on elastic parameters, not just petrophysical parameters. Then you have used another algorithm for let's say lithofacius classification, and it is based on self-organizing maps this way. And self-organizing maps we have used gamma ray and PF logs and resistivity and other logs. We have seen that gamma ray and PF influence on 3 neurons, while the two resistivity logs are the same way. And the results are shown here for different logs and for dependency conditions. The obtained results are shown here. For some are shown here. Yeah, for some wells, you can see the results obtained for well 1, for well 532, for 12595, and so on. For 240, 256, 532. We can see in this part that we have presented two approaches for AI. One is based on MLP, material perceptron, and second is based on self-organizing maps. The MLP have been used to estimate the missing logs. It gave good results for density and PUF, but not good enough for sonics. The self-organizing map also is used for classification of lithofacias, where to give good results for the four fasces. What is recommended from this part is that we implement this petrophysical parameters like porosity, permeability, and SW. Also to construct a 3D model for porosity, which we have done in the previous example. Then permeability, which we are going to do through the tortuosity factor and also SW. So also dynamic modeling of water saturation based on injection data in case of production reservoirs. Another example here is the fuzzy clustering algorithm for lithofacius classification. We have used fuzzy clustering in order to classify the fasces based on their appearance. So it is noticed that from the previous lithofacius classification is that we consider only the primary fasces. So for each interval, we have only one fasces. However, we may have two fasces on the same interval. And for the secondary one, we have to consider because it may have an influence on the petrophysical evaluation. The fuzzy clustering used here is for this example. I showed that we can also calculate for the secondary fasces. But it's not enough. For that, what we have done is we have used neurofuzzy algorithm. Neurofuzzy algorithm means we have implemented artificial network algorithm with a fuzzy logics, where the synaptic weights are calculated through the fuzzy rules, or let's say membrane rules, what we call membrane rules. So this is the algorithm is shown in here. And what you can see here is the fasces. Here is the primary fasces, 1, 2, 3, 4, 5, and 6. And here you can see the secondary fasces. For example, 7 is the secondary fasces between 1 and 2. 8 is the secondary fasces between 2 and 3, and so on. And here is given for different wells. And you can see here they obtained the results for the some wells from Algeria. You can see here it's better discrimination, and it should be should improve the petrophysical evaluation and reservoir characterization for development. As a conclusion and recommendation of this presentation, I can say that artificial intelligence are useful and important tools for problem solving in petroleum industry in general and exploration and production activities especially. But if available data is used, so the convergence and reliability of the obtained AI solutions depends strongly on data availability and also its QC. So if data is not reliable, it will give us anything. It might not converge at all. So this is very important, and the QC is tremendous or a crucial step before applying any kind of artificial intelligence algorithms. The solution provided by artificial intelligence feasibility is related to problem complexity degree. So, for example, someone told me, okay, I will just apply artificial intelligence for solving the equations of, let's say, the inverse problem of seismic inversion of, let's say, um, trapezoid equations. We cannot, it's too complicated, complex problem. For that reason, you need to have huge amount of data, reliable data, and high computational capacities. And even if you have these two things, you may not converge to a given solution. So because the problem is overestimated, and there are many aspects that have been ignored. As a compromise, I can say that as a compromise between algorithms requirements and the expected models, it is necessary to use smart and intelligent way to explore artificial intelligence. And recently, I'm reading some aspects about artificial consciousness. So people are now talking about artificial consciousness. So that's a question from artificial intelligence to artificial consciousness. Weird. So when we arrive to this step, we have to step back and ask questions. What is intelligence first? And what is consciousness? And is intelligence a result of consciousness? If so, does consciousness an ultimate fact? And what is intelligence of conscious being? What is intelligence of a human being, for example? This is a big question. I think we should step back and ask this question, and then we may arrive to a bigger question, which is what is beyond science. So this is a big question. Generally, we end up a presentation by giving answers, but I'm just ending up with giving more questions than answers. So at the end, I would like to thank Inas for giving me this opportunity, and I would like to say, it's not a fact, but it is my opinion. I think that consciousness is beyond science, and therefore artificial intelligence can never be conscious, and it is just designed to replace a human stupidity. Today is June 19, which is coincide with the death of one of the young Algerians, and I would like to take this opportunity to address a message to all young Algerians to dream big and to try to do whatever you want in your life, but not just dream, but you have to follow your dreams and work hard, because hard work works. And I will quote what said Ahmed Zabana in this day 66 years ago. He said, when he executed, before execution, by the Quatin. Quatin is المقصلة in Arabic. He said, "I'm happy because I will be the first Algerian to be executed with a Quatin." So for you as young student, young Algerians, I don't want you to be executed, but I want you to be the first Algerian to do something. So choose anything that has never been done before by an Algerian, and follow your dreams and do it. Thank you so much.
Thank you very much, Dr. Dorman, for the very, very insightful presentation, the full presentation, and the very powerful message you are sharing with the young generation in this platform. So we're very, very, very happy and to see your conclusion here. Thank you again. So you really covered the topic and you touched the nail, as you say. You started with a very introducing the artificial intelligence history from the beginnings, and then you covered some projects on the oil and gas industry by the big players, and then finally you kindly shared with us your expertise on using machine learning and artificial intelligence, which is a hot topic indeed, on petrophysical characterization, even for geophysics characterization, using geophysics as well. So really, really glad to see your presentation. Thank you again. I would like to remind our audience that you can ask your questions in the comment sections, and we did indeed had a lot of comments and many questions in the chat box here, and try to pick few questions. Many people are thanking you for the very insightful presentation indeed. So let's move to the Q&A session, and we'll pick a few questions from our audience here. I remind you that you can ask your questions in the comments, both in French or in English, right? So feel free to ask any questions. All right, so okay, first questions from Fatah Boubeli. What are the first steps? What are first steps should Sonatak follow in order to start using AI, artificial intelligence, in the oil field?
Well, it's a very good question. I think the first step is to, as I said, that artificial intelligence is a solution. It can be a good solution. It can be a bad one. It can give you a good solution if you give it good data. So I think the first important step, which is already being done by Sonatak, is digitalization, data digitalization at QC. So it is a very important step because if you don't have data, you cannot do anything about artificial intelligence. And if you don't have reliable data also, you cannot do anything. So already Sonatak has started the policy of digitalization, and as I said, ASH1 and ASH2, which is the first step of any project. So I think this is the most important thing, is data. It's the digitalization of data and QC, reliability of data. And it is, let's say, it is the crucial and the most important ones for any artificial intelligence solutions.
Thank you very much for the answer. We will block another questions, this time from Facebook. Thank you very much for the very interesting topic. I think there are many end-user softwares offering open source solutions to enhance their capabilities using Python. What do you think of that?
Yeah, this is a good remark. Thank you so much for this one. Yeah, of course. Probably most of end-user softwares have open source part. For example, Techlog has its own part, Petroleum has C++, and so on. Yeah, it might be a solution. Yeah, of course. Let's say, for example, Techlog is developed. It contains the module of artificial intelligence. However, I would like, for example, to see a new algorithm developed in artificial intelligence that's been implemented in Techlog, for example. I don't know why companies do not give such importance previously, but now I think it's coming. It's coming. Not Schlumberger, but most of companies are working hard in order to implement new modules and new solutions for artificial intelligence in the end user softwares. So, however, what I'm thinking here is to find a solution based on local problematic. So this is very important. If you do that, if you can do that through Python or Techlog, that's okay. So it's okay. So it's more than welcome. If you can do it with C++ in Petroleum, that's perfect. So what is important is to try to find new solutions that does not exist in the modules of software, to catch up the technology, to catch up And of course, different companies are all the time taking notes about the local problematics and trying to adapt their end user softwares to the local users. So this is very important. But I think as a programmer, I'm not a good programmer, I'm not perfect, but I'm trying to learn more. And in order to learn more, you have to program a lot.
Thank you very much. I agree with you, especially in the age of the openness, in the internet. I think ignorance is a choice, and we definitely can get many things out of the internet and make them to our own need. I'll pick up another question from LinkedIn this time. Is it mandatory to auto-digitalize maybe to all database in all fields, seismic, reservoir, drilling, production, before starting this project? Probably he's talking about a more general view of automation for like a digital
automation. It's the same question. Yeah, question from Fatah too. So Fatah, I think auto digitalization. It's not. I don't agree with this term a lot, because digitalization, it means you are trying to give a machine reliable information. Because you cannot do reliable information if you do it in an automatic way. So, as an example, I'll just give you an example. For example, when you log into your account, you will use, generally we have some procedures for checking if you are not a robot, right? So
exactly.
who designed? So who decide at the end if you are a robot or not? It's a robot. It's a machine. So you see the contradiction over here. So we cannot advance in such a way. Of course, yeah. If we arrive to auto-digitalize the process based on concept, human concept, I'm okay, agree with you on that. But in order to auto-digitalize, I will give you anything.
Thank you very much for your response. I take another question this time from Facebook. I think Sonatak have a lot of old well data since the 70s that can significantly help to train new drilled wells. Is there any digitalization project to retrieve all archives using artificial intelligence?
Well, as far as I know, there are some solutions, but they are not mainly based on artificial intelligence. They are based on some types of algorithms and something like that, but it's not artificial intelligence, as far as I know. I'm not sure if all doesn't exist. I can't tell you because I don't know anything. I don't know everything, but as far as I know, to the limit of my knowledge, there are no projects in that sense.
Thank you very much for your response, Dr. Dolman. For myself, I have a question about the colored seismic inversion part. Yeah. So, did you use the seismic inversion to constrain your machine learning model, or what's the purpose of the inversion part you explained at the end of the presentation?
Yeah. First, it's called inversion. I used just to extract the volumes of acoustic impedance, density, and other cubes. Then the training is done only near wells, so just for the wells, in order to construct a relationship, let's say attribute, mathematical relationship, which is not linear for sure. It's not cross plot or something. It's more complex. Then I will try to scale up in order to apply this attribute for the whole volume. So the colored inversion is just to extract the three cubes from the original data, from the raw data. However, what is important here is the optimization of the artificial neural network itself, because we have used laptops generally are not performant enough. So with a huge amount of data like seismic, so we were obliged to go through the optimization of the algorithm itself or the architecture of itself in order to optimize the calculation. Is it the most optimal architecture? I'm not sure. There is no way for that. So what we have done in order to optimize three parameters at the same time, it's too difficult. So we have fixed two, but the choice of the ranges for which we have is not arbitrary. So it's based on our experiences and tests. We have just chosen some ranges. Then we fix two parameters and vary the third one, and so on till you obtain an optimized one. But it is the most optimal. Not sure for that.
Thank you very much for your response, Dr. Dorman. I think we are a little bit running out of time, so we'll not take further questions. By the way, everybody is thanking you very much for your very insightful presentation.
Thank you.
And everybody sends my regards. So,
Dr. Hamoush, I'm just want to address special thanks to my colleagues at the Department of Reservoir Evaluation and generally in the Hassim Saoud, because I have passed through some technical problems in the few days, and I have help from Basti Abdel Moumen, Gemri Idir, Salih Boufanchouch, let's say, yes, Yusuf Hamdawi. I don't want just to forget anyone, but I will try. If I forget someone, I'm sorry. So I would like to thank you all.
Thank you very much, and thank you everyone who's helped you on this presentation, and thank you again for accepting this. Maybe Sarah, any final questions before we close this call, and many personal questions maybe from this presentation today?
Yeah. First of all, thank you so much for this insightful presentation and the interesting topic. It was basically a topic that covered many aspects, and I'm so happy to see artificial intelligence in another perspective, just without seeing, let's say, some forms and so on. So first of all, thank you so much for that. I just have one question in mind about the integration of this team related to this kind of project. Do you rely only on petrophysicists or computer scientists as well? How the combination of the team is gathered for this kind of project? And thank you so much again.
Yeah, this is a very interesting question. For the project, we have too many different persons, especially petrophysicist, geophysicist, PhD student for automation, PhD student from computer science, from mechanics also. So we have different disciplines. Computer science, unfortunately, we don't have one specialized in computer science. So we have to do this work by ourselves, programming languages and so on. So we do it by ourselves. But for the other disciplines, we have too many disciplines. I would like also to thank my PhD students because they are working too hard, and especially the new ones and the old ones too, who defended their thesis this year and last year. They work too hard, and they have proved their competences in many occasions. So it is, and also I told them, hard work works all the time.
Yeah. Thank you so
much.
You.
Hard work pays all the time. Thank you very much for this beautiful words. And with that said, we would like also to thank all our audience. Thank you very much. Thank you everyone who've been following us in this very, very important presentation. I remind you that we are going to have a monthly webinars in this project where we are inviting worldwide experts and Algerians and non-Algerians to share with us their expertise in the field of geoenergies and renewable energies. So next month also, we are going to invite another keynote speaker. So stay tuned in our us page so that you can see who is going to be our next panelist. With that said, I would like to personally thank again Dr. Dorman for his very insightful presentation. I thank Sarah also for co-moderating today's session, and thank you everyone for participating online in this meeting. You can review the meeting recordings and you can share it with your friends if you want. Thank you very much.
Thank you.
Thank you so much.